second type of the control system, that is on the size of the compensations. So we are done one. The first one was the phase split network, and now we want to focus on the phase lag network of compensation. So we want to look at phase lag. So we want to focus on the phase lag compensations. So what do we mean by this? This is a system which has only 1 0 and balls dominating, meaning the balls are closer to the origin. So this is a system which has only 1 0 and the balls in this system is dominating, and what we mean by that is because the balls are closer to the origin. Maybe you can just revise kidogo what we talk about the balls last time. We say when we have the balls, the system becomes unstable, and again the response is slow. The system response is slow, but we have the ball has got one very useful feature, and that is the system is very accurate. The system is very accurate. So this uniqueness of that system of the ball is what makes it to be used in compensating network. So the phase lag, the ball is dominating, and the uniqueness is that the system is very accurate, though it has got some weakness, and one is the unstable system. The system will be stable. Of course, it will be combined with other system to improve the stability and the speed of the response. But the one feature about this which need to be noted is that the system is very accurate, and the balls appears to be at the origin of the S plane. So let's see the diagram. The capacitor. So that is the wiring diagram of phase lag compensations. The phase lag compensations. So it behaves like that. We want to derive the transfer functions of the same system, and then we see how it appears. So we want to derive the transfer functions of this system, and we know transfer function is V out all over V in. So we can start from the V out. V out is given by, we have this current going in that direction. So V out is equal to the voltage drop across the resistor and the capacitor. So it's going to be that I into R2 plus SC. That will give us that. Further simplifications, you can have C R2 plus 1 all over SC. Multiply by I. You go to the V is going to be I into R1 plus R2 plus 1 over SC. So we can now substitute from that formula V out, V in. So V out is this SC R2 plus 1 all over SC into R1 plus R2 plus 1 SC. I and I will cancel each other and we shall have this equation. So we shall have V out all over V in to be equal to SC R2 plus 1 all over this and this. We shall have SC into R1 plus R2 plus 1 plus 1. So we can say let alpha be equals to R1 plus R2 all over R2, and then let the time constant be equal to C R2. So this is what we are going to get finally. V out is going to be equal to SC R2 plus 1 all over this one is going to be, you can have C R2 into, we want to modify these equations, so R1 plus R2 all over R2. We are introducing that just to have this one plus 1. So the ratio that we are going to get V out and V in is going to be equal. S here is this, so we shall have SCT plus 1. This S is this, divided by this is this, so we are still going to get ST. Okay, this is the alpha plus 1. So V out all over V is going to be equals to ST plus 1 all over ST alpha plus 1. Now we can be also asked to represent this, represent this on the S plane. So how are we going to do that? This is what we are going to do. So we are going to equate this to 0. We're going to say ST plus 1 equals to 0. Then we say also ST alpha plus 1 equals to 0. Now you look for the value of S. So S is going to be equals to -1 divided by T. Here S is going to be equals to -1 all over alpha T. So drawing the S plane,